Long Beach. Next Friday, Saturday, Sunday. I am a speaker. Yeah. No, they're doing a science hour. They just needed a talking scientist, and I can talk as a scientist. Yes. And I figured out how to stream handwriting really easily off of my iPad using Air Server. So I solved my problem. We should go live. Oh, okay. I did not know that. Okay. I can hear him.
There. Now they should be able to hear me. I was mucking with my technologies today, so it's not surprising that they couldn't hear me.
Okay.
Yeah.
Hello, everyone.
There. Yeah, there. Now you can hear me. But you'll never know what I said. It will be lost into the history.
The energy is simply radiating away into space.
Yeah.
The energy of your words.
I'm going to present today's episode in mime. So today's going to get weird. Just to warn you, Pamela's got to travel next week to the Twitch thing that she was talking about.
And the Division of Planetary Sciences. I have 2 trips.
2 trips.
One to Utah, one to Long Beach. And I have to come home to St. Louis in between the 2 of them because government travel is stupid.
They say that I'm quiet. They just want to smash all computers. Okay. I know how to fix this. I can fix it. Fix it, Felix. No. Do I want to do this? Yes, I do. So I'm going to go loud. All right. I'm going up to 112 decibels.
That's more than 11.
I'm going to go to 120%. So I'm going to 12. All right. So now we should be... You're probably still going to be a little quieter than me.
Maresy dotes and dozy dotes and little lambsy divey.
Yeah. Yeah. But anyway, I've got a pile of boxes over here that make audio go, and each one affects what happens next downstream. And so
this is called a circuit.
Yeah. And so each one, and some like will constrain the amount of noises that I make. Others will boost the amount of noises that I make, but others will make them quieter again. So the goal is to just like mellow me out, to just chill out the noises and the sort of the yelling and the when I get really excited and like, oh my God, that's amazing, and that doesn't get transferred through the system.
You have a mixer box, a mixing board?
I've got a. Someone will know the technical term for this thing.
Okay.
It's a gate.
You have a filter. Do you have something with a whole bunch of knobs, or do you have a whole bunch of little square boxes that everything goes through?
It does. It's a compressor. That's
okay.
What it is. So we've got.
Okay.
We've got the bottom box here. So first my audio goes into this box, and I can boost up the gain, which I want to do, and then this thing changes the threshold, so how loud I can be, right? And then this kicks the audio back out, and so you can see as I'm getting really excited up here is the output level, right? I'm like, oh my God, it's really cool. And it gets really loud. And then it goes into this guy, and this is an interface for the computer. So it turns an analog audio into a digital audio.
See, I'm old school, so I've been trained that when I'm really excited, I need to lean back far away from the mic, and then I come forward when I'm not excited anymore.
Well, you're the consummate professional. So
I also can't afford the thingies that you have.
it wasn't expensive.
It's okay.
It wasn't expensive.
Really?
It was like, yeah, no. It was
Okay.
like $40, $50.
Oh.
Yeah.
Those used to be a whole lot more expensive.
It just does one job. Its job is to smooth out the audio. So if I just get too quiet, it's supposed to be good, and if I get too loud, I don't know. It's an audio engineering thing. But as always, like that is, well, my dad always used to say, house finish, man die, right? So, you will work on your house for your whole life. And it's when you're dead is when you stop working on your house. Or maybe that's how it works on Hornby Island, where I come from, is everyone's always working on their houses.
My house was built in 1893. We will really never have it
Right.
Yeah.
But in the end, it'll be audio setup functional, Fraser die. That's how this is going to work. There's a big difference in volume between you. 20% at least. Oh my God. Okay, let's go louder.
Okay, I will sit back.
No. Oh, that's weird. It is kicking up your audio.
So if I'm too loud,
No.
I can just lean back.
It's like autumn.
Do you have a ghost in the software?
I've made myself louder.
Mersey dotes and dozy dotes.
What? Okay, I'm going to more decibels. Even more, but yeah, Pamela self-compresses. I like this. Okay. It's fine.
That's what I
it's
do
fine,
to
really.
sleep on
People are like,
airplanes.
it's fine. Okay, and today's going to get super weird. So here's how this is going to play out. We've got to do 2 shows because you're traveling. I've got to book out around 1:30. So we're going to do 2 shows really quickly, and then we're going to hit the road.
And there will be Patreon office hours for those of you who support us on Patreon as soon as the show is over.
Yeah. Okay.
I'm going to forget everything that I learned about weather satellites before we start recording.
No, that's important. That matters. All right. I'm going to do this the cheap way. I know people are like, it's fine. It's not fine. I know it's not fine. Go just a touch louder. There we go. Does that look? Did you hear that? All right. Just a touch.
I heard it.
A little.
Was I supposed to hear it?
Yeah, a little goes a long way.
Okay.
All right. I'm going to press record. Hey, if you're wondering what it is you've stumbled into, this is an episode of Astronomy Cast. We're going to do 2 episodes. First one, all about weather measuring, and the second one,
Weather
all about...
satellites.
Sure. Weather satellite measuring. And then we're going to do an episode about modeling. So what the future sounds like. So, all right. Here we go.
I'm recording.
What?
I've been recording since you said you were recording.
I never said I was recording, but we should start recording now.
Chad, you have 33 seconds to cut off. I'm sorry.
No, just start your recording.
Okay, fine. Killing what I did. Pressing record. It is now recording.
I'm also recording. Whoa, that's really quiet. There's no way Chad is going to be able to use this.
What is wrong with your system?
I was messing with my audio box, and and trying to. Okay, so we're gonna have to start the recording again. So what happened was Chad reported to me that there was a audio problem with my side of that there was like a hum that was coming through, and the hum comes through when a person has too much gain that's being sort of boosted up, and so the problem is that I had this. So I'm gonna try, and this. Oh man, I can see this is not gonna be good. All right, we'll see what happens. But we're gonna need to stop it again. All right.
I am pressing record. Hello, Chad. I hope you like my levels. I'm sorry that Fraser's levels are sad.
I know, yeah, but I have also pressed record. Here we go. Astronomy Cast, episode 461, Measuring the Weather. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific and the Director of CosmoQuest. Hey, Pamela, how's it going?
It's going well. How's it going with you, Fraser?
It's going really well. This is very, very well timed, I think, now that we've been seeing all of this crazy weather coming our way. So we've got a special two-part episode about the weather, which is going to be a lot of fun.
And this is one of those episodes that really came out of Susie asking me, so what should we have as a show topic? While I was looking at a website that was like, and a hurricane is headed towards Ireland, which is not where hurricanes normally go. And it was just sort of like,
is that
the weather?
Is that even possible? Wait, hurricane going to Ireland?
Yes. I'm looking at its track right now. And what's kind of amazing to me, which is why we're doing the particular two-parter we're doing right now, is when Hurricane Ophelia first spun up as a tropical depression and then a tropical storm out in the Atlantic, it looked like it was just going to do this little corkscrew out in the middle of the ocean and harm no one. And then they showed it increasing to a category 1, but it showed that it was never going to get stronger than a hurricane 1. And then I woke up yesterday to a notification on my phone saying that it had become a category 2. And when I first looked, it was like, and it shall never be a hurricane 2 past this point. And I'm now looking at the model, and it's been a hurricane category 2 for quite some time. But as it has every time I've looked at this page since this little hurricane spun up, the next weather model's like, and it shall become a category 1. And I no longer believe it. But yes, its track is straight on track to hit Ireland.
And this is not like I don't know much about the weather, but as I recall, hurricanes form off the coast of Africa or perhaps down in the Gulf, travel across the Atlantic Ocean and smash into the Caribbean,
the East Coast
of North America, or they form out in the Pacific Ocean and smash into the coast of Asia. They don't go the other way.
Yeah, so the Azores actually have a hurricane/tropical storm advisory going on. The Azores are islands off the coast of Portugal. They have weather alerts in Portugal and Spain. And this is the kind of Atlantic hurricane that normally just doesn't get seen, but has led to lots and lots of asterisks in the weather saying this could have happened in the past, but we wouldn't know because when it happened, there weren't satellites. So we're going to talk about satellites.
Awesome. And I didn't even do my intro. Here we go. What's the weather doing? Is it going to rain today? How much? What about temperatures? We depend on modern weather forecasting thanks in part to the vast network of weather satellites. What instruments do they have? What orbits do they use? Tell me more.
Well, so where would you like to start?
Well, so let's talk about sort of what is sort of the modern suite of weather satellites. What is up there right now?
So you and I here in the North Atlantic and rather Northern American continent are overseen by satellites that have been put up by the by NOAA and NASA. And these satellites are in two different kinds of orbits. We have satellites that are in geostationary orbit and just sort of hang out directly above the Earth's equator, a bazillion miles up, and just stare at one point all the time. And then the other kind of satellite that we have is a polar orbiting satellite that comes across the exact same sun incidence angle on the surface of the planet every time it orbits around the Earth. These are much lower, they have much higher resolution imagery. And because they constantly see the planet at the exact same sun planet angle, you end up with things like they get referred to as the afternoon satellite, because that's the orbit it's on, is to see the Earth in the afternoon.
So about how many of them are there?
For us, we currently have 5 up in orbit. These are the GOES satellites, but all different nations have all different satellites. So the entire planet ends up basically swarmed with these polar orbiters and these geostationary orbiters. And since each of them is interested in their own special places, the geostationary ones were pretty good about keeping out of each other's way. But the polar orbiters, what's cool is the polar orbiter that works for you and I works for both you and I, because as the planet rotates, we at different points come out underneath the spacecraft. So the polar orbiters sweep out the whole world, and there's a bunch of them up there. So you never quite know who it is that's looking down.
Right. That doesn't sound insidious and creepy. They're there to help. They're there to help you forecast the weather, and that's a good thing.
It is. It is.
So what is on a typical weather satellite? What is the suite of instruments that they're using to analyze the Earth?
So the ones that we're most familiar with, because these are levels that we can readily turn on and off in Weather Underground, weather.com, whichever suite of software that you're using to look at the weather. The ones we're familiar with are, we're going to look at the Earth in the same wavelength that your eyeballs see. This is the visual imagery that you see of the Earth. Other ones that we use are infrared. This is where we look down at the planet and can start to tell what is the temperature, what's cool is once you start looking at temperature, you can start to see different ocean currents, because the water that's in a current will be a different temperature than the water that's just hanging out at a given latitude. So we have this whole suite of different visual bands and infrared bands. Now, beyond that, it's cool to be able to see things in visual and infrared, and that's what a strictly weather satellite does. But we also have environmental satellites, and environmental satellites can get used for the weather, but they get you a whole lot more information as well. They start to look at how the atmosphere reflects light of different wavelengths in ways that tell us where is the atmosphere. Let me say that again. I'm sorry, Chad. They start to tell us where is the atmosphere filled with different aerosol chemicals. So this is where we can start to see the ozone, the problems with the ozone. We can see smoke layers as compared to cloud layers. We can see smog, sulfur streams in the atmosphere. We can also start to get at what is the wind speed from different reflective capabilities. This is where Doppler and microwave starts to matter.
I mean, so we were actually mentioning sort of before the episode, we're just talking a bit and saying like just how good the weather system is now. Like, I don't know about you, but a lot of people out there, like I'll be somewhere now and I can start to depend on what my phone says. Like, it's going to be here on the West Coast, we definitely want to know when it's going to rain, which is all the time. But still, we look at the weather. And it'll say like, oh, it's not going to rain until 3 o'clock, and then it's going to start raining, but then it'll be done around 5 o'clock. And I find myself, before, I just knew it was all worthless. And now I find, you know what I mean? Like, you're just like, forget it.
Yeah, you lived on the West Coast. Me growing up on the East Coast, we were pretty good.
Well, but did you really used to depend on weather forecasts, or did you just like go like, well, he was wrong again, talking about the weather, the weather forecaster?
I was one of those children that would look at the weather and decide if I had to really do my homework or not.
Why? Because you thought you might get a snow day?
And I often did.
And you often did. But I'm sure that went catastrophically wrong. But I mean,
didn't, because and this is what is amazing in how our satellites have changed over the years. Is every few years we add the ability to get more and more information. And this comes with the upgrades in what satellite systems that we're using. So we're currently using the GOES satellites, which I often make fun of because they don't always rename them as quickly as one would wish, or they refer to them in strange different ways. So there is the GOES-R series of spacecraft that get referred to as GOES-R. Then there are some of them that, depending on what orbit they're in, are referred to as GOES-E or GOES-W because of East and West. There's occasionally a GOES-S. And when they're still being built, they all have numbers. And then they rename them to when they're being built, they all have letters. So they recently constructed one that, while it was being built, was called GOES-P. And the second it hit orbit, they renamed it after a number. And so
what? Why? I don't understand.
So anyways, this particular series of satellites was able to totally get my attention by the crazy system they have for referring to them. And GOES is of course an acronym because it's a spacecraft. So of course it has an acronym. And in this case, it's Geostationary Operational Environmental Satellite. So GOES. And there's a whole suite of them that have a variety of different orbits, a variety of different instruments. And the instruments they have on them have changed over the years. And so now we have them that they have imagers, they have spectral suites, they have the ability to detect X-rays, to detect ultraviolet. They do lightning mapping. So when you see those weather layers that show all the little flickers of where lightning has happened, that's getting measured by a satellite. They have magnometers on board so they can study the interplay between the solar radiation, the Earth's magnetic field. And this is what they do today. But each of these different instrument suites have gotten updated over the years. And so the situation that we're in right now is we have a bunch of them up there. They keep some in storage in case one dies. They keep some going all the time. And so what we have right now is GOES 15 is in the GOES West location because they have to make you giggle while they go over the names. They have GOES 13 is in the GOES East position. And where things get sad and where satellite isn't always enough is there's also a GOES South position that used to always be occupied by a spacecraft. But we had a spacecraft die, as they sometimes do. So GOES 10 was decommissioned in 2009. And initially the GOES 12 took over for it. But then it was retired in 2013. And now there's no one living in the GOES South position. And so we're missing a set of data.
Well, there's people living there. There's just not a satellite living there.
Yeah. So we have an East Coast satellite, we have a West Coast satellite, and we currently have nothing in the southern position. And what this essentially means is we're not getting all the data we used to get. So there was this brief period up until 2013, when we had the modern satellite design, we had all the instrumentation, we had all the satellites in all of the spaces. And that was when we were able to do the amazing forecasts for the snowmageddon that happened on the East Coast. We were able to do these amazing forecasts for all the nor'easters that tried to bury New England. And now you'll notice that the past couple of years, the forecasts just haven't been quite as reliable. And it's because we're missing a satellite.
But for a certain region.
But the thing is, you need to have the data from all of the regions. And this is actually what started me down this particular rabbit hole is growing up on the East Coast. I had all of the weather stations from where you were on the West Coast, all across North America, that were doing ground truth data. Some of those stations actually report their data up to the satellites, and then it all gets sent down together. And all of this data from all across the landscape would go into the models where I grew up. But where you grew up, there's a giant ocean to the west of you. And it's out of that west that your weather is coming.
Sure does.
And yeah. And nowadays, we have better infrared imagers that are able to better take into consideration thermal models of the ocean. We have better models that can better study the interplay between that ocean and the atmosphere, but that's the next episode. And by having better satellites, better instrumentation, more data, that wasn't there when you were growing up. And there weren't the man-made weather stations in schools and farms. And so you had insufficient data to correctly forecast whether or not you were going to have a snow day.
Right, because there was nobody out there in the Pacific watching the storms come across the Pacific to reach us, while people in other parts of the country, for example, you could see the weather systems coming down from the north or coming from the east as necessary. So yeah, maybe that's why my childhood was it was hilariously wrong weather. But so you talked about this missing satellite. Then are there plans to fill this hole?
So we're launching another satellite in December. And so the open question that we're waiting to find out is when the new GOES satellite goes up in December, will, as it takes the position on, I forget whether it's the East Coast or the West Coast, will the satellite that's currently stationed in one of these must-have positions, will it get redirected into the GOES South position, or will it get put into a standby orbit and held to be used later if it's needed?
Now, you're talking about the GOES satellites, but that's only a chunk of the Earth focused on, say, one country. Well, Canada uses them
continent.
As well. One continent, one hemisphere, but there is other parts of this planet. So there's other weather satellites focused on other parts of the world.
And here, again, each nation has their own satellites. They do not have equally well discussed on the internet satellites. And this, we have to say, actually, thank you to the US government for spending so much money on education and public outreach, because NOAA and NASA have both been able to dedicate time and money to explaining on the internet what it is that their satellites do. Now, with Russia, we have the Electro satellites, which operate out over the Indian Ocean. The Japanese have their MT sats, which are out over the mid-Pacific. And I'm going to mispronounce this, but it wouldn't be an episode of Astronomy Cast if I didn't mispronounce something. The Himawari are out at 140 degrees east. Europeans have the Meteosat series of satellites, and China has the Fangguan series of satellites. And finally, India has INSAT. Now, if you'll notice, there are only like North Hemisphere satellites listed there. Now, the nice thing about geosynchronous is that since they're up over the equator, the whole globe is sharing these satellites. And it just turns out that the nations able to launch them right now are North Hemisphere nations.
So is there sharing then between, because as you said, the NASA stuff, the NOAA stuff, that's all just online. Anyone can go anytime they want and see this stuff in pretty much real time. They've got some really cool. I was sort of demoing this. You can go to certain pages. You can scroll your mouse wheel and just push the weather back and forth, which is really cool. And it's sort of, they've mapped the weather onto the classic blue marble. So it's more of a simulation, but still you can see sort of what the weather's been doing. Thanks, NASA, for making all of that material available in real time to the public. Is there sharing? What is the level
Yeah.
of kind of availability and accessibility for this kind of stuff?
So in general, there's two different kinds of satellites. There's the military ones, which because the military we don't really know anything about. But then the public satellites are largely globally shared. This means that the GOES data gets used by everyone. The European Metasat data gets used by everyone. And because we're sharing, it's leading to better models because the Europeans have their own hurricane models, the US has its own hurricane models, and we're all working on the same data and we can focus on the maths because we don't have to focus on getting the data. So this is super useful. And then with polar orbiting satellites, we're even in a different position because it turns out that the polar orbiting satellites, because they're closer to the planet, because they're on a much shorter orbit, they're actually seeing the whole planet 2 times a day as they go zipping around and around and around. So we don't even need quite as many of those.
Yeah, it's
so
really
for
important
polar orbiting,
it's really important to sort of understand the distance of these geostationary satellites. Because the way it works, you've got to be tens of thousands of kilometers away from the
basically
Earth.
36,000 kilometers or 22,000 miles.
And that's far. When you think about like where the International Space Station is, they're only about 500 kilometers above.
240 miles.
240 miles. Yeah, so it's 300 I forget, 50 kilometers. Anyway, so they're not very far away. And so they get that big, beautiful view of planet Earth, while the folks at those satellites that are out of the geostationary orbit, they're 20 times, 50 times farther away. And so they're just not getting the same kind of resolution. They're not seeing the same kind of weather, the smaller formations that are happening inside. And that's why these polar satellites are so valuable.
And the polar satellites they're higher up than the space station, but they're still close enough to the Earth that they can start to see things like if there is a large flock of fishing boats out off the coast of Japan, they easily turn up. So here what we're looking at is NOAA has a series that are conveniently named NOAA 17, 18, 15, whatever. They're just NOAA satellites. That's easy. Europe has the METOP and EUMETSAT, EUMETSAT. I'm not sure how people say that one. And then Russia has the Meteor and Research series satellites, and China has the ever ineloquently named FY3A, 3B, 3C. And India has some that I don't know the names of. And so again, it's the same sets of nations. It's India, Europe, China, the United States. And Japan has their geostationary satellites as well. And as they're up there orbiting the entire planet, sending the data back, because these satellites are only 850 kilometers up, they do have that much, much higher resolution imagery.
And there's actually some really fascinating orbits. We did a whole episode on orbits a long time ago. But with the polar orbits, you can pull off kinds of orbits that sort of mimic a geostationary orbit, but by using this really sort of funny elliptical orbit and sort of coming into the Earth while the Earth is turning, and get a very, be in the sky for quite a while before, having to swing around the Earth.
Those get used for communications, but they don't actually get used for weather. With weather, they always do sun synchronous orbits. So these are orbits where they actually refer to them as morning orbits, afternoon orbits, where the sun is always at the same angle relative to the planet. And this allows you to always see shadows the same way, so that when you have a difference from one image to another, it's not because the sun moved, it's because the coloration on the surface of the world changed. So if farmers' fields appear significantly darker from one image to the next, they probably got soaked in a rainstorm. If you see a brightening of the surface, that's either frost or snow or water that's reflecting sunlight. And so with the polar orbits always being sun synchronous, it gives you the ability to see things on a much more regular cadence than you would get with the communication satellite orbits. And it allows you to not have to worry about the chaos provoked by shadows.
Yeah, yeah. So if I always like to give you the blank check, and you get to go and purchase some future weather satellites, future weather imaging capability, measuring capability. What would you like to see? Especially if there's like a
Oh,
decadal
man.
survey, or what kinds of things you think the scientists are looking for?
So if I were given an unlimited budget, what I would want is a whole series of the advanced GOES satellites that are evenly spaced around the planet, every 20 or 30 degrees around the planet, uh, allowing us to get this continual monitoring with the entire instrument suite, and then have a morning, noon, evening, midnight. So have basically this 4 different time slots for the polar synchronous orbits, so that we have constant suite of data coming in, even spacing, get symmetric, identical coverage, because this is what makes computers so much happier. Once you're able to start getting even coverage of the entire planet, you start being able to do models that take into account all the different things happening in the world. As we mentioned at the beginning of the show, hurricanes originate as hot air coming off of Africa. And so we need to understand what's going on in Australia to be able to keep track of the Pacific El Nino, and we need to be able to keep track of the currents in the Atlantic to understand when is a storm going to stall out. So we need all the data, all of it. I want all the data,
All the data.
all of it.
I think about the upcoming SpaceX, Elon Musk, 4,200 communication satellite constellation that could go up when the big freaking rocket launches, and think about the weather and just Earth observing capabilities that those things could provide. In addition, it would be a mind-bending capability of a weather network as well.
And what we really need to do is start thinking more in terms of how can we create a network of satellites that is accomplishing multiple different purposes. It was actually the early weather satellites that were used for global positioning. And it was just a test. It wasn't highly accurate, couldn't be used to test the innermost details of relativity, but it was proof of concept. We have the ability to double up what these satellites are used for, the same way we currently double up that they can be used to check for emergency transponders. And by having this grid of emergency responders, satellite weather data coming in, and this means we have communications, we have position, and we have weather, and these are all public services. And if we can have a combined network that takes care of us for all these different things, it really starts to put us in a safer world.
Well, here ends part one. Part two, we will be talking about putting those satellites to work, predicting the future. Thanks, Pamela.
Thank you.
All right.
And now we save.
So I'm gonna shut down the stream, and I'm really sorry to do this, but we want to keep everything into 2 parts. So everyone is going to want to shut down this one, and in a second, the new stream is going to pop open. I just got to get it all set up. So hang tough. But there will be no more show where you're watching it right now. So we'll see.
Go to the other URL.
Go to the other URL. Make sure you have notifications turned on, so then you'll get.
Yes.
Yeah, your phone will freak out when another episode is happening. All right. Thanks, everybody. We'll see you over there.